All right, so today we're going to be talking about box plots, how to determine the shape of a distribution from a box plot, and percentiles. So box plots you've probably seen before, I think, right, in your careers as students. But just as a refresher, a box plot provides a visual tool for analyzing information about a data set. And so it's made up of 5 numbers, which we end up calling the 5-number summary. But when we create a box plot, these points here at the beginning and the end, this is the minimum value and the maximum value. So these lines go out to them. This is why it's also called a box and whisker plot sometimes. Those would be the whiskers. And then there's these 3 lines in the middle that make up this box here, the box part of the box plot. And so the middle line is the median, which we've learned about already. And then the first part of the box and last part of the box are the upper and lower quartiles, also known as Q1, the lower quartile. Oops. And then Q3, or the upper quartile. The median also sometimes is called Q2, but we usually just call it a median. But just so you're aware, sometimes it will be referred to as Q2. And one thing about quartiles is that they split up your data into 4 parts, where it's the same number of data values are within each quartile. So like this is 25% of your data, this is 25% of your data, 25% of your data, and 25% of your data. So quartiles divided up into quarters, hence the name. So 25% of data, 25% of data, 25%, and 25%. So it's just a way, again, like how the median divides it up in half. Half your data is above, half your data is below. Quartiles then divide it up one more time. Okay, so the 5-number summary, like I said, is made up of these 5 numbers that we use to create the box plot. And you can get this 5-number summary directly from your calculator in the same way that we got like the mean and the standard deviation and all that stuff. So the 5-number summary is the minimum, or min x as your calculator likes to call it, Q1, the median, Q3, and the maximum, or max x as your calculator calls it. All right, so determining the shape of a distribution from a box plot. If we have the whisker part of our box plot here, if these are about the same length, and the median is towards the middle of the box, then this is symmetric or normal. And then we have, if the right side is longer, the right whisker is longer, similar to like when we were looking at histograms. If the tail went off to the right, this would be skewed right. So that's the main way to determine, just by looking at the whiskers, but also usually if it's skewed right, the median is also more towards the left of the box. but usually looking at the whiskers is the best way to determine, because sometimes the median would still kind of be in the middle. And then going the opposite way, if the left side is longer, it'd be skewed left, and if the median is a little more towards the right, it would be skewed left. Okay, so how we determine the 5-number summary again is we used all the same steps that we did last week when we were doing the mean and median and standard deviation. So you hit the stat button in your calculator and then select the first option, edit, and you're going to enter in your data values into L1. Remember, if you need to clear a list, hit the up arrow so L1 is highlighted and then hit clear, enter. Don't hit delete. We don't want L1 to disappear. So enter data into L1. So give you guys a couple minutes to do that. Again, remember, clear, enter. Clears your list. Don't hit delete. And then once you have all of your data entered into L1, then in order to get the 5-number summary from your calculator, you hit the stat button again, go over to the calc menu, and then select the first option, 1var stats. And then you hit enter until all of that information pops up on your screen. This is the same as what we did last week. Then if you scroll all the way down to the bottom of that list of information, you'll see your 5-number summary should be given to you right there in order, where it has your the min x first, which should be 20. Then your Q1, which is 22.5. Median, 23.5, Q3, 26, and max X, 35. Okay, any questions how to get these numbers? Again, we get them the same way that we were doing the stuff last week. It's just where to look in that long list of information your calculator gives you. So now to actually create your box plot, we need to draw a number line. And with box plots, you need to make sure that you are using even increments to label your number line. You can't just label it with just the 5 numbers of your 5-number summary, because you have to have the correct spacing in between everything. So I'll have my number line here. You don't have to start at 0. You can just have to make sure all your 5 numbers in your 5-number summary can fit in where you choose, but you do have to, again, go up by even increments. So I'll just start with like 15, and I'll go up by 5s. Okay, so again, you don't have to start at 0. You just have to make sure all your numbers can fit. So look at your max and your min. And then Q1, median, and Q3 get the vertical lines to make your box. So 22.5, 23.5, and 26 to make our box. And then we have our lines going out to the min and the max. So 20 and 35. Okay, so again, it's important you use even increments so that with this next question, when we're determining the shape, you have an accurate representation of the lengths of each of those whiskers. Determining the shape, our right side, our right whisker is longer than the left, and our median is more towards the left of that box. which means we're going to be skewed right. Okay, questions about box plots. So then moving on, the last thing we're talking about today is percentiles. So a percentile tells us the percent of data values that are less than, so strictly less than, not equal to, the given value. Bless you. So in order to calculate the percentile of a number, you just need to count the number of data values that are less than whatever number you're looking at. Again, not equal to, strictly less than. And that'll be your numerator. Number of values less than the number for the value. And then you divide by your total number of data values. And then that'll give you a decimal, so you'd multiply by 100. And with percentiles, you always round to the nearest whole number. So you can't have like 77.6 percentile. It'll just be the 78th percentile. So you always round to the nearest whole number. Okay, so example, we have test scores of 30 students listed below. We want to find the percentile rank of 84. So to find this percentile rank, we first need to find the number of values that are less than 84. And strictly less than, if it equals 84, it doesn't count. And in this case, since there's 30 total data values, we would divide by 30. So we just look at our values and we just got to count how many are less than 84. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 1, 2, 3. So there's 23 data values that are less than 84. You divide by 30. You need to multiply by 100. So this will, not 1,000, 100. This will equal 76.666 repeating, right, when you do that. However, again, with percentiles, we always round to the nearest whole number. So since 6 is bigger than 5, we would round up to the 77th percentile. And so this means 77% of the data is less than 84. So 77% of your students scored less than an 84 on that test. Okay, we can work backwards. If we're given a percentile rank, we can figure out what data value it's referring to. And so it'll kind of be like a solve for x problem again, like what we were doing with weighted averages a little bit. So if we know our percentile rank is 30, we'd have 30 equals the number of values less than x, whatever our x is representing, over 30 times 100. So to solve for that numerator, you would divide by 100 and then multiply by 30. So you would get 0.30 times 30 equals the number of values less than x. Bless you. So 0.3 times 30 gives us 9, I think, right? So again, this is just the number of values less than the number we want. This isn't an actual value, it's just telling us a number to count. So if we look at our data values, we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, which means the next value has 9 values less than it. So you can either just count and look at it that way, or if you want to think about it as 9 plus 1, it'll be the 10th data value. But again, you have to get the actual value back from your data. 9 is not a data value. So it'd be 65 has a percentile rank of 30. Okay, so that the main thing again is just remembering if you're doing this solve for x1 where you're working backwards, the number you get is a number of data values. It's not an actual data value. Okay, do you guys have any questions? All right.